Hi children, welcome to a special edition. See, this video is meant for JEE Advanced students particularly, and we would like to have a broad coverage into the depth of a particular concept selected, not to the 100%, but to the possible extent we are trying to demonstrate questions and content that is coming for the IIT Advanced exam. All of you know, if you take an IIT Advanced question, say for example, one matrix match type or comprehension type, different area, different conceptual points which are linked together is coming in the question. For example, a matrix matching type question, if there are four matching, four in the list, and each matches with the 2-3 options, each one can be considered as one single question for the other exams. So one comprehensive question turn, when you split up, it becomes some 10 questions. That is the nature what we observe in many questions. Not all, there are direct questions for IIT also. Not all, but many questions are of that standard. So what we are doing with this video, this is particularly meant for, as you can see the caption given, Grignard reagent. I would like to discuss the various aspects of handling questions based on Grignard reagent, which is given as a splitted questions. When all these splitted questions incorporated into one platform, that may turn as one single question for IIT Advanced. Hope you understand what I mean. And in that whole coverage, probably what we generally observe is some 80% points we know what we deal in the NCERT or what we deal in the subject course of study. But 20% it may be out of our knowledge. So that is where we lose our marks. And that is where we need to concentrate when you prepare for IIT exams, right? Let's go through the demonstration of particular points which I have had a talk now based on a single content. Today it is a single content based on Grignard reagent and its various characteristics. That is my point of discussion. Welcome to the video. Okay. So we have one first question. There is A, B, C, D available from the above given, which all cannot form a Grignard reagent. Which cannot form a Grignard reagent. Suppose we take option A, this treated with magnesium in dry ether. You see what you will get is, there will be Br, CH2, CH2, MgBr. It forms a Grignard reagent, but what happens is, after that is, it is breaking over here as plus and minus, and this will be breaking as minus and plus, and this electron will migrate to the position, and the product obtained is ethene. You get ethene. So the question is, which all cannot form a Grignard reagent. So this cannot form a Grignard reagent. That is one answer. Okay. Now the next one, option B. What is happening over here? Once again, you can see it is, you are getting like this. Once again, it will break over here plus and minus. It is breaking here minus and plus. So it will be attacking over here, and the result will be cyclopropane. Cyclopropane. Here we got ethene, and here we are getting cyclopropane, and that is yet another answer. And I think many of you are aware of the same kind of reaction which is happening with the zinc. It is happening with the zinc. Zinc will take away the 2-bromine. And you will get cyclopropane. You get cyclopropane, the so-called Fruend reaction. Fruend reaction, right? I'm just reminding you. Yeah, fine. Next, What about C? C. So A will not form Grignard reagent, you get ethene. B will not form Grignard reagent, you may get cyclopropane and sometimes even propene also. And option C, what about option C? Option C, it is happening in the same way. You will not get a Grignard reagent. As you can see, you are getting MgBr over here and Br over here. It's breaking here plus and minus. This electron pair will be shifted as it is breaking as Br minus. You will get benzene and you can take this as a route for proceeding with the benzene mechanism. You can take this as an opportunity for proceeding with the benzene mechanism, which we find the reaction with the metalamides and all, benzene derivatives reacting with the metalamides, giving various such addition, elimination type of reaction. Such reaction initiated benzene mechanism can be treated over this way. So that is yet another answer. While this is not the answer, as it can form Grignard reagent, as it is 1,3 position. It is 1,3 position. It can form Grignard reagent. Right? So the answer for the question A, B, C. This will be one part of a big question comes in front of you for the IT exam. Right? Next one. Here we have again 4 choices available. Among the following, which all give addition reaction with the Grignard reagent, which does not, which give addition reaction and which does not. That is the question. Option A is very popular and known to all. Option A, very popular, right? RMgX plus carbon dioxide. It is polarizing as minus and plus. It's breaking here plus and minus. Minus will be attached here and O minus will interact this. Preparation of carboxylic acid, RCOOMgX, which upon hydrolysis over this part you get RCOOH, carboxylic acid is obtained. Preparation of carboxylic acid, a very important reaction that we learned in the textbook. What about option B? So this will give addition reaction. Option A will give addition reaction. What about option B? Option B, it is CH3CH2Br with RMgX. You see, it will break as minus and plus, and it is breaking here as plus and minus. Minus will undergo a substitution reaction, and you get CH3CH2R plus MgBr2, like that. So it is merely a substitution type reaction, SN reaction. So that is not. This is not. So A, yes. B, no. What about C? C is similar to A. C is similar to A. How is the reaction happening? RMgX, I don't know whether you have noticed that reaction or not. You can see it is breaking here as plus and minus. It is polarizing as minus and plus, and it is adding over there. You get RSOOMgX will turn OH. So you get acid. The way we are getting carboxylic acid, you can get sulfonic acid. Right? So that is also yes. What about D? D is no, because there is an acidic hydrogen. The presence of acidic hydrogen, the Grignard reagent is highly sensitive and is converted to corresponding alkane. What's happening with the D? In option D, you have acidic hydrogen. It is interacting with the RMgX. There will be acid-base reaction. There will be acid-base reaction, and R minus will with H, you get a RH. So that is not. So A, C will give the reaction, B and D will not. Right? Yes. Another one. So all these which you can understand from the coverage which you find, certain points which we haven't noticed is going to be there in the question, and lack of information or lack of knowledge in that part is going to affect in ID exams. Next one, the product obtained in each of the following cases with the RMGX. What is going to get here? This with the RMGX. You see, it's breaking minus and plus. This minus will be attacking here. You get RCOR. And that again reacting with the RMGX, you will get tertiary alcohol. You will get tertiary alcohol. Option 1. First one. You get tertiary alcohol, non to almost all. The same thing will happen here also. It's going to break minus and plus. You will get RCOR and you will get RCOH, RR. Nothing to comment. Nothing to comment. So with the acid chloride or acid esters, we get tertiary alcohol. First you get a ketone, then tertiary alcohol. And remember, if you are dealing with the ester of formic acid, you will be getting aldehyde. From there to secondary alcohol. Okay. What about here? It's a ketone, will give you tertiary alcohol, RCOH, R tertiary alcohol. And this is an aldehyde, you get a secondary alcohol. You get a secondary alcohol. So option A, first ketone, then tertiary alcohol, ketone, tertiary alcohol, secondary alcohol. That's it. Nothing special. Okay. Next. Write the product obtained in each case. Write the product obtained in each case. See what is the product obtained in the first case. You can see this is the Grignard reagent part, so pH will be coming here and you get a tertiary alcohol and the product is CH3, COH, CH2, CH3, pH. That is what the product. Fine. What about the second one? What about the second one? This is the Grignard reagent part that will be added here. Hope you understand the product in first and second case are same. The same product is obtained. See, that is another way which we usually come across. Different combinations giving same product. So here you can see A and B reaction. Combination is different, but the product is same. Right? What about C? What about C? Here it is an ester. Here it is an ester. So first you will get a ketone. C6H5CO CH3. This is the CH3. And further you will get a tertiary alcohol C6H5COH CH3. This is what product, but that is different from the AB combinations, right? What about D? What about D? Wow. In D also the product will be same. The product will be same as this. So A and B, whatever the product obtained, you are getting same in option D also. Same you get in option D also, as you can see, CS3, CS2. So what will be the combination? It is CH3, CH2, CHOH, and there is CH3, sorry, PH, and CH3. This will be coming on this carbon. So CS3, CS2, C, PH, CS3 means the same product, So option A, B, D. Combination is different, but the product is same. Combination is different, but the product is same. C, it is different one. Right? So these type of questions which is encountering in the more than one choice, correct? Or even in the matching type question. Okay? Matrix matching. Next. So in fact, what it is being done here is the different idea that is incorporated in a big question, we have split it and is presenting here. Okay, fine. Next. Which of the following compounds will give acid-base reaction with RMGX? See, there will be addition reaction over here, and that is not the answer. And this is an answer, it is giving H plus. It will give H plus and there will be acid base reaction, you will get RH. This will give H plus and there will be RH formed. And this will give addition reaction. So A and D will give addition reaction, while B and C, this is hydrosulfuric acid. See, even Grignard reagent is sensitive to water. H2S is more acidic than water. So H2S definitely will give acidic H plus. So, and that's going to be sensitive for Grignard reagent. There will be acid base reaction converting to hydrocarbons. So B and C, C is formic acid, B is hydrosulfuric acid. Fine. Next. That is something related to the correct statement about a Grignard reagent. First statement, CMG bond of Grignard reagent is covalent but highly polar, carbon being positive relative to electronegative magnesium. See, this part is, first part is correct, but the second part is wrong. So option A is wrong statement. RMGX give nucleophilic addition. Option B is correct. RMGX give tertiary alcohol with esters. Yes, RMGX will give tertiary alcohol with esters, while if you are dealing with the ester of formic acid, you will get a secondary alcohol. That's a different case. RMGS give nucleophilic addition reaction with acid derivatives. Yes, with esters, with acid chlorides, you can get addition reaction. So all the statements are correct except option A. Next. RX with magnesium ether, RMGX, methanol, N-butane. What can be R? What can be R? You are getting N-butane as the final product. What can be R? Suppose you are dealing with the N-propyl. This is N-propyl, CS3, CS2, CS2, Br. Converted to Grignard reagent, you get CH3, CH2, CH2, MgBr. And that is treated with methanol, CH3OH. This is having acidic hydrogen and this is sensitive to that. So what happens is plus and minus. This minus will be interacting with the hydrogen. You get propane. You get propane. So if you take option A, you get propane. That is not the answer. It is option B, N-butyl. Option C, secondary butyl. And option D, isopropyl. A and D will give you propane. Whether you take normal propyl halide or you take isopropyl bromide. This is isopropyl bromide. The result will be same, propane. Similarly, when you take normal butyl halide or secondary butyl halide, the result will be same. Suppose we are taking normal butyl halide. Suppose we are taking this part will be converted to MgBr, and that upon treating with H plus, you will get a butane. Suppose you are dealing with the secondary butyl bromide, CS3, CHBr, CS2, CS3. This part there will be Grignard reagent. Upon interacting with acidic hydrogen, this CH will turn CH2. This CH2 will turn CH3, you get a normal butane. So here this CH2 turns CH2, you get normal butane. So whether N-butyl bromide, whether you deal with the N-butyl bromide or secondary butyl bromide, the skeleton part converted to corresponding hydrocarbon, you get a normal butane. Answer is option C and B. B and C, you will get a normal butane, right? Next. There is a sequential reaction available. Bromobenzene with the magnesium ether. A is nothing but Grignard reagent. A is nothing but Grignard reagent. Now, that interacting with acetone, this interacting with acetone, you get a tertiary alcohol. This is what you get. But that subsequently treated with acid medium and heating, there will be dehydration, and that will be compound B. There will be dehydration. So the compound B will be an alkene. This will be the compound. This will be the compound B. And now B treated with the NBS. I think NBS is known to all. N-bromosuccinimide. This is NBS. N-bromosuccinimide. This is N-bromosuccinimide. NBS. N-bromosuccinimide, which is an allyl brominating agent. Allyl brominating agent. And you can find allyl position. There will be halogen coming. Halogen coming at a allyl carbon, and the compound C will be this one. This will be compound C. Allyl carbon, there will be bromine coming. That is compound C. And now with the moist silver oxide. Moist silver oxide is equivalent to silver hydroxide. Most silver oxide is equivalent to silver hydroxide, and it gives solvolysis reaction. That bromine will be replaced by OH, and that is D. Compound D will be OH. You get OH, and now it is treated for ozonolysis. It is treated for ozonolysis E and F. What will be E and F? What will be E and F? See, ozonolysis happens over here, and this will turn formaldehyde, and the other part of the molecule will turn ketone. This part of the molecule will turn ketone. That is E and F. So what is E and F? E can be E and F. That can be, one is formaldehyde and the other is a ketone. A ketone formed over there. That is E and F. E and F. Now, what are the products given? Product C. Product C. Product C. Product C is correct. Option B. Product D. Product D. Product D is correct. Option E. Product E. Product E and F. E and F. E and F. Methanol. Methanol. And F. 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 That is also, in fact, all the choices are the products obtained in that sequential conversion, right? And that's the end of this particular discussion, which important characteristic features of Grignard reagent tried to incorporate is that, see, this is not over. The characteristics of Grignard reagent is not over. This you can take it as an episode dealing with the important characteristic, different characteristic, different way it is interacting in different situation, which is incorporated in a bulky question that we find in IIT exams, right? With another content, another concept, another important area of discussion. We will meet in next video. Till then, bye. See you. Take care.